Alrighty, Secondary Math 1 class. For today's notes, we are going to be talking more about adding and subtracting radicals. So we've been working a lot with our radicals. Radical is another word for basically the square root symbol, okay? So let's get right into it. So for number 1, I know I've made you guys do this a ton of times, but we're gonna do it some more, okay? So it's asking us to list the first 11 perfect squares. So I want us to make a list, just like you know how to do, from 0 all the way to 10. Okay, so your list should look like mine. Okay, all the way from 0 to 10. Okay, once you have those numbers on your paper, you can go ahead and multiply those numbers by themselves. Okay, 0 times 0, 1 times 1, 2 times 2, and so on. Okay, so now your list should look like that. So each number has just been multiplied by itself. Okay, so now that we have that, let's go ahead and rewrite it as itself squared. Okay, meaning 0 times 0 we can rewrite as 0 squared. 1 times 1, 1 squared. 2 times 2, 2 squared, and so on. 3 squared, 4 squared, 5 squared, 7 squared, 8 squared, 9 squared, and 10 squared. Okay, so now your list should look like mine. Now that we have that, let's figure out what is 0 squared. What is 0 times 0? Well, 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is not 2. Is 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. And 10 times 10 is 100. Okay, awesome. So these numbers in blue are really going to help us. Okay, so now what I want you guys to do is look at numbers 2 through 5. Okay, look at the numbers inside your radical or your square root. Are any of these numbers in this list up here in blue? If they are, put a star by them. Okay, the only number that I saw that's up there in blue is 64, right? 64 was the only number up there in blue. Okay, so we're gonna save that. Just put the star by number 4, and let's go ahead and practice simplifying these radicals some more. Okay, so we have the square root of 18. So the 18 is not a perfect square number. It's nowhere in blue up on that list. So we have to simplify it, meaning we have to divide it down in order to get pairs of numbers. Think they can pair up and go on a date, right? So 18 is an even number, so I know I can automatically divide it by 2. Okay, when I divide 18 by 2, that's going to give me 9. Okay, so I don't quite have a pair yet. Remember, once you break down a number, it's not there anymore, so we just have a 2 and a 9. Okay, I can't break 2 down anymore, but I can break 9 down, and I love 9 because 9 is one of these numbers in blue. If it's one of these numbers in blue, we know it automatically gives us a pair, right? So 9 can be broken down to 3 and 3. Okay, so once I have my pair of numbers, it's completely broke down, so I know that those 3's can pair up. They create one couple that got to leave the radical and go on a date. This 2 is the only one that's left, so our answer is 3 root 2. Okay, awesome. Let's look at number 3. So the square root of 125. Okay, 25 is one of our numbers in blue, but not 125. Okay, but that might actually help us in a second. So remember 25. Okay, so I need to break down 125. I know that 125 ends in a 5, so I can divide it by 5, right? So if I divide this by 5, I get 25. Okay, remember how 25 is one of those awesome numbers in blue? What pair does it automatically give us? It automatically gives us a pair of 5s. Okay, so all of our numbers are completely broke down. So we have 3 5s. So how many of them can pair up to go on a date? 2 of them. And it does not matter which 2 you grab. Okay, so we know that 2 5s can go on a date. They create that one couple. 1 5 was left inside. So our final answer is 5 root 5. Okay, let's look at number 4. Square root of 64. So we put a star by 64 because it's one of our numbers up here on our list. Okay, that means that it is a perfect squareable number. Okay, or in other words, if we wanted to break this up, we know it automatically gives us a pair. And 8 times 8 gives me 64. Okay, well, once they already create that pair, we know it can automatically come out. Nothing is left inside. So when it's a whole number just left, we know that it's a perfect square. Awesome. So let's look at number 27. Okay, the square root of 27. This number is not on that list in blue, so we need to divide it. So 27 is not an even number, so we can't divide it by 2. But what can we divide it by? We can divide it by 3. Okay, 3 times 9 gives me 27. And again, 9 is one of these awesome numbers in blue, so it automatically gives us a pair, a 3 and a 3. Okay, so we can see that 2 3s can couple up. Again, it doesn't matter which 2 3s you grab. Whoops, sorry. Okay, they create one couple that can leave. Okay, and there was 1 3 that had to stay inside. So our final answer, 3 root 3. Okay, so let's look at 6 and 7. Okay, so 6 and 7 have something that we haven't done yet today. Okay, they have variables. So we talked about simplifying radicals with variables inside last time. Okay, so it follows the same rules of any numbers. It has to be able to pair up in order to leave. Okay, but we're just going to ignore it for now. We're just going to pretend like it's just root 18. Okay, so let's go ahead and simplify 18. Hint, we've already simplified it. It's up here on number 2. We're going to go ahead and do it again. So you know that 2 times 9 gives me 18. Okay, 9 is one of those awesome numbers that gives me an automatic pair, so 3 times 3. Okay, so we know that 3 can couple up and leave my radical. I'm going to leave a little space just in case there's anything else that can leave. Okay, from that, the 2 had to stay inside. And we're done simplifying the 18. Now all we got to worry about is the b. Okay, so we have b cubed here. So that means b times b times b, or b multiplying by itself 3 times. Okay, so there's 3 of them. So how many can couple up to leave? We get 2 of them. Okay, they create one couple that got to leave. How many is left inside? 1 of them. Okay, so we know that our final answer is 3b root 2b. Okay, so the variables follow the same rules. They have to pair up in order to leave the radical. Okay, let's do the same thing for number 7. Okay, so we already simplified 125, but we're going to do it again. So I know that 125 ends in a 5, so I'm going to divide it by 5. 5 times 25 gives me 125. Okay, 25 is one of those awesome numbers that gives me an automatic pair, 5 and a 5. Okay, so we know that 2 of those 5s can pair up to leave the radical. I'm going to leave a little space just in case anything else can leave. Okay, 1 5 had to stay inside. Awesome. We've simplified the 125 part. Now all we need to simplify is the p to the 4th part. Okay, p to the 4th we can also write as p times p times p times p. Okay, well, how many couples can they create? Okay, I see 1 and I see 2. So all of the p's got to leave. They created two couples, or p squared. Okay, none of the p's had to stay inside, so our final answer, 5p squared root 5. Awesome job. Okay, let's look at 8, 9, and 10. Okay, so what's weird about 8, 9, and 10? Oh my gosh, we have more than one radical, and we're adding and subtracting them. So we see subtraction signs, we see addition signs. Okay, so let's write our rules. So I want us to make this note on our paper. Okay, so rules for adding and subtracting. Okay, adding and subtracting. So the first rule, you need to simplify if possible. Meaning you need to simplify the radicals just like we've been doing. Okay, our second rule is then to combine like terms. Meaning they have the same number inside the radical. Okay, so those are our rules for adding and subtracting radicals. Okay, as long as we follow these guys, we'll be totally fine. Okay, so let's do number 8. Okay, let's follow these rules for number 8. Okay, so the first thing we need to do is simplify the radicals if possible. Okay, very important, that if possible. So let's look at these 2's. Okay, you're always looking at the number inside the radical in order to simplify. Okay, we can't break 2 down to get any pairs. They're already simplified. Okay, so these guys are already simplified on number 8. Check. So we don't have to simplify them. Okay, now we just need to do rule number 2, combine like terms, meaning they have the same number inside the radical. So look at the numbers inside the radical. Whoops, for number 8. Are they the same numbers inside? 2 and 2? Yeah, they are. So now we can just combine the coefficients. So all we have to do is look at our coefficients, the numbers in front. Okay, so this is like saying 3 root 2's minus 5 root 2's. Okay, what is 3 minus 5? It's going to give me negative 2. Okay, and then we just have to write it. Negative 2 root 2. Okay, in other words, you can think I have 3 apples. I'm taking away 5 apples. Okay, that root 2 is just how we label what we have. Okay, so we have negative 2 root 2's. Okay, so let's look at number 9, because we might have to do some simplifying here. Okay, so let's look at our first radical. Okay, and don't even look at the number out in front. Remember, the number out in front is already a couple that's waiting to go on a date. Just look at the 54. Let's go ahead and simplify the 54. Okay, we're just looking at that guy. So it's even, so I know I can divide it by 2. So 54 divided by 2 is going to give me 27. Okay, I can't break down 2, but I can break down 27 to a 3 and a 9. Okay, I still don't have a pair yet. I have a 2, a 3, and a 9. So let's break down 9, 3, and 3. Okay, so they're all broken down. So I only see one couple that can go out and leave on a date. Okay, so it's going to be that 3. And that's going to multiply to the 3 that was already out front. So let me zoom out a little bit so you guys can see. Okay, so that 3 is going to pair up, go on a group date with that 3. So what is 3 times 3? What does that become? It becomes 9 root what? What was left in there? I see a 2 and a 3. Okay, well, these guys have to stay inside. So what is 2 times 3? 6. Okay, awesome. So let's look at our second one. We simplified our first one. Let's look at our second one. This one's already root 6. Well, we can't simplify this root 6 anymore. So we know we can't simplify this one anymore. So all we got to do is just bring this one down. Okay, so we did the first one, we did the second one. Now let's look at the third one. So just root 12. Okay, so let's break up or divide root 12. So I have 2 times 6. Okay, and I can break 6 down to a 2 and a 3. Okay, well, what number gets to pair up and leave here? It's actually the 2. And the 2 multiplies by this invisible -1. So 2 times -1. What is 2 times -1? It's going to give me a -2. Sorry, this is kind of going into the rules. Okay, what number was left? 3. Okay, so we did rule number 1. We simplified if possible. Now we need to combine like terms. Which ones have the same number inside the radical? Okay, I see 9√6 and I see -2√6. We can't combine it with √3. Those aren't the same. So the only ones we can combine are 9 minus 2. So what is 9 minus 2? It's going to give me 7√6s. Okay, and since we cannot combine it with -2√3, we just put it on the end. -2√3, and there is our answer. So we had to simplify, then we had to combine which ones had the same numbers under the radical. Okay, let's do it one more time. Look at number 10. Okay, we might simplify. Okay, in fact, yes, let's simplify first. Okay, you might see something different about 10, but keep it in your thoughts. Okay, so let's go ahead and simplify. So we're going to simplify 12. So we have 2 times 6, again, 2 times 3. Okay, so I know that the 2 gets to come out. It multiplies by the -2 that was already out front. So we get -4√3. Okay. The same thing's going to happen when we simplify this 12. 2 times 6, 2 times 3. Okay, so again, we get another group of 2 that comes out. It multiplies by the -1 now. So that's going to be -2√3. Okay, let's do it one more time with this 12. 2 times 6, 2 times 3. Okay, we get a group of 2. It multiplies by the 3. Okay, so this actually turns into a +6 since it's adding it. √3. Okay, so we simplified. We did our first step. Now we just need to combine the ones that have the same number inside the radical. So look at these guys. Do they have the same number inside the radical? Yes, they do. They all have √3s. So now all we got to figure out is what is -4 minus 2 more, and then +6. Okay, if you want to do this in your head, you're more than welcome to. You can also do it on a calculator. I always allow that in here. Okay, so what was it? It was -4 minus 2 plus 6. And that's going to give us 0. Okay, well, 0 times anything, even √3, is 0. Okay, so that was kind of a weird one. Okay, notice from the very beginning, it also had the number, right? The same number under the radical. So technically you could have seen that and combined like terms, you still would have gotten to 0. Same answer. Okay, those are your notes for today. You have a corresponding assignment. Great job, you guys.